So as soon as
I'm done.
yeah, cool, good, good. Amar, you done?
Yeah, I'm done.
Okay. So we're going to move on to the next bit. Right. Now, how many of you, you can just say on the mic if I ask you if you have the answer, how many of you have drawn probability tables in school?
I don't know what that is.
No,
What
that
does
is.
it look like?
Okay, I'll show you now. Yeah, let's talk about it a little bit to explain it. So, probability. Let me just make this ink a bit thinner. It looks a bit nasty like that. Okay, much better. Probability, outcome, tables. So imagine, so a situation. Yeah, I'm going to give you a situation. Situation is this: I throw 2 die. Die is plural for dice. List all of the possible outcomes. List all possible outcomes. So what you need to do here, I'm going to make a table of all of the possible outcomes when I throw 2 dice. So let's start by looking at 1 dice on one axis and another dice on another axis. And we're going to talk about how this works. So if I throw the first dice, I can get a 1, okay? I can get a 2 from the first dice. I can get all the way up to 6. So I'm going to draw them all out. And the reason I'm drawing it is because you might not have seen this before. So we'll do it fully. 4, 5, and 6. That's my first dice. So my first dice, I've said all of the possible outcomes. On my second dice, I have a similar situation. I can get 1, 2, 3, 4, 5, and 6. Okay. So when I throw the 2 dice at the same time, the first one might land on 1, and the second one might land on 1. So I get 1 and 1. The first one might land on 2, and the second one might land on 1. I get 2 and 1. The first one might land on 3, and the second one might land on 1. I get 3 and 1. And so on and so forth. I can fill the table. So here we get something like this. This dice over here might land on 4, and the other one might land on 2. This dice over here might land on 4, and the other one might land on 3. So do you guys see what's going on? I get all of the possible outcomes by drawing a table. On the table on one axis, I have all of the possible outcomes for one dice. On the other axis, I have all of the possible outcomes for another dice. This is also known as a two-way table. Why? Because I'm getting 2 different situations and bringing them together. In a probability outcome table or in a two-way table, I list all of the possibilities of one situation at the top. I list all of the possibilities of the other situation vertically down. I then make a chart, and in each box, it will tell me what the different combinations are. Does that make sense, guys?
Yeah.
Yeah? Khalid?
Yeah.
And Hannah?
Yeah.
Okay, so now that we've done that, we are ready to continue with some exam practice before we move on to the next topic. So exam practice, let's look at it. I'm going to pull out a probability test here. You'll see it in a second when I share my screen. If you guys remember, these are the questions we done last week. The pizza question, the chicken pie question. I did send you guys a homework. Did you guys manage to do any of it?
Homework?
Yeah. I sent a homework by email to a lot of people.
I never, no, I don't think I got.
No problem. I'll send it to you again. Yeah, but I sent this paper and a few other things. Now I know about the people not answering that either they didn't get it or more likely they didn't do it. It's fine. Okay, what I'll do, I'm just going to pull out the mark scheme. because we're going to look at that as well in a second. So I'm going to put out the mark scheme, put that on the other half of the page, and we're going to practice this. It's very important to practice. Let me just minimize that. Get that over here, oopsie daisy. Get that over there. Get the mark scheme on the other side. Okay. Now, so last week we finished around here, question number 2. All right. I want you guys to think about this question. It's a 2-mark question, which means it shouldn't take longer than 2 minutes to think about it. So read the question. Tell me what you guys think. Shout out your answer as soon as you get one.
I think he's correct.
He's correct in a sense because he can only have 2 things, win, draw, or loss. However, if you're playing against another person, what if he's better than you at chess? Then do you have an equal chance of winning, losing, or drawing, or are you more likely to lose?
More likely to lose.
Exactly. So the probability doesn't only depend on win, loss, or draw. It also depends on how good the other person is. So in this case, it's not 100% correct. If I'm playing with my football team of Hackney and I play against Liverpool, I haven't got a 1 in 3 chance of winning because Liverpool are going to be a much better team generally. Yeah. So therefore, I'm more likely to lose. So my probability is determined by everything in that situation, not just win, loss, or draw. Does that make sense, Hannah?
Yeah.
Okay, good. I think, is that okay, Khalid?
Yeah.
Yes. So as you're answering these questions, I hope in your books you have a little section saying exam paper questions, probability, because when I send you this exam paper, I think some of you have already got it, you know where the answer in your book came from when it comes to time to revise. Okay, let's do the next bit. Number 3, try 3A and 3B out. Go on.
Is it 7 out of 25?
The first one, yeah, the first one is excellent.
Yeah.
Because if you have 7 out of 25 probability of something happening, that's going to be the same every day. If I have a 7 out of 25 probability of doing something in my week, it means I have that same probability on a Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So this question is just to help you understand that if you have a probability of doing something during a particular time, like a week, then any time within that, which could be a Monday, Tuesday, Wednesday, whatever it is, the probability will be the same. Does that make sense, Amar?
Yeah.
Good. Okay. So the next bit about expected. Tell me what you guys think. Anyone get an answer? Just tell me.
I'm not really sure.
Not sure?
You do 7 over 25 times by 20.
Yes, you do. Let's go through that.
Oh,
Can you guys see my whiteboard? I've just put a whiteboard up. Can you see it?
Yeah.
yeah.
So remember what we said was, if you want to find the expected probability, it's the actual probability multiplied by the number of outcomes, by the number of times you're doing something related to that probability. Yeah, so number of outcomes. In this case, we have 20 possible outcomes, okay? Because if she does it 20 times and the probability of getting late is, what was it? I'll tell you if I remember. The probability of getting late was 7 over 25. If the probability of getting late is 7 over 25, then my expected is going to be, I'll call it E for now, 7 over 25 times 20. That will give me 5.6. Does that make sense?
Yeah.
Okay. Now, one important thing here, which I'm going to teach you through this question, is this 5.6. You can't, so you're expecting her to be late 5.6 days out of 20. There's no such thing as 5.6 days. So what do? Just round it up. If she's going to be late 5.6 days, we can just call that 6 days. She's likely to be late on 6 days. If it was 5.4 days, she's likely to be late on 5 days. So the answer to this question here, after you get your 5.6, just round it up to 6. Because you can't have 5.6 days of being late. Not possible. Does that make sense, Khalid?
Yeah.
Okay, Amar
Yeah.
and Hannah?
So every time you just round it.
Yeah,
Yeah.
you round it. Because if you want to, it's the number of outcomes you're going to have. So you're looking at expected, meaning how many times do you expect something to happen? You can't have 5.6 times or 4.2 times. The number of times something happens has to be a whole number usually. Yeah? How many times did I go to the park? 4 times, 5 times, 6 times. I didn't go to the park 5.5 times. So what you do, you take this number and you round it up to get a realistic estimated value. Okay, good. So let's go to the next one. Can you guys see the exam paper again? Just anyone can answer. Khalid?
Yeah.
Okay, cool.
Yeah.
All right, let's go to the next one. Now, the spinner is spun twice. Draw a table showing the possible outcomes. Something we just done. So I want you guys to draw a table showing all of the possible outcomes. You spin it twice. What numbers are you going to get? If you throw dice twice, what numbers are you going to get? Similar thing. If you're confused, let me know. And then, if you do that and think you can go further, here is the rest of another part of the question. So if you remember our dice example, we're going to look at that. We're going to look at something similar now. So I'm going to just open this smart scheme up and show you what's going on here. Go up, go up, go up, go up, go up. Do you see that table there?
Yeah.
Okay. I'm going to show you how that table comes about. Okay. So what we're going to do, let's minimize this a bit. Go over here. Bring that over there. Bang. And new slide. Okay. So you've got this spinner over here, yeah? I'm just going to put my mouse over it. You can get a 1, a 2, a 3, or a 4. So when you spin the spinner once, your outcome might be 1, 2, 3, or 4. Okay. Now, remember when we had the dice, we looked at the outcome of one situation first. So when I spin that spinner, I might have these outcomes over here. But when I was spinning the spinner once, well, how many times does the question say we're going to spin it? Someone tell me?
4.
Why?
The question says
4, 5.
the spinner is spun how many times? Look at where I'm highlighting.
5.
Twice, yeah? Do you guys all agree with that?
Yeah.
Yeah? Okay, good. Now, so if I start drawing that out, if I spin it twice, that means I've got 1, 2, 3, 4 going on this way. I'm also going to have this 1, 2, 3, 4 situation going downwards. So let me just draw that out for you. This thing's going on steroids. Here we are. So 1, 2, 3, 4. Then I'm going to have the second spin, which is going to give me 1, 2, 3, and 4 as well. So we have that, and we have that. So I spin the spinner once. Let's say I spin it once, and I spin it again. And on both goes, I get 1. I get 1, 1. I spin the spinner, and I get the number 2 on the first spin. On the second spin, I get the number 1. So I might have 2 and 1. I spin the spinner, and I get number 3 on my first go, and I get number 1 on my second go. So I can have 3 and 1 as my combination. I spin the spinner, I get a 4 on my first go, and number 1 on the second go. So when I spin it twice, I get 4 on the first go, 1 on the second go. I might spin the spinner and get 1 on the first go and 2 on the second go. 2 on the first go, 2 on the second go. 3 on the first go, 2 on the second go. 4 on the first go, 2 on the second go. Do you see what's going on, guys? I'm building up all my combinations.
Yeah.
Okay? Is it still confusing, Omar?
No.
No? Good. Okay, so what we're going to do, I'm going to show you guys the answer to that, and you can copy the answer down for now, this box over here on my screen. I'm circling. Once you copy that box down, your next step is to look at that box. Oopsie daisy. Or do make your own box, actually. It'll be better. After you make your own box, I want you guys to try and answer these questions here. Okay? Again, if I'm going too fast, let me know. If anything's confusing, let me know.
I've done all three.
You've done all three, yeah? Okay. Hannah, how many have you done?
I'm on the second one.
Okay, lovely. Okay, I'm going to give you some time to do the second one and the third one whilst I explain the first one. So the first one, the total is 7. What's the probability that I'm going to get a total number of 7? What that means, Amar, is, let's look at the question in a little bit more detail. First of all, what is the probability that the same number occurs twice? So how many, when you're looking at probability, Amar, you're doing this. Let me just pull up my whiteboard screen. Can you see my whiteboard, Amar?
Yeah.
Okay. Whenever I'm looking at the probability of something, I'm doing the following. So the probability of something will always be, oopsie daisy, let me just make this a bit neater. The probability will always be the outcome that I'm interested in. So the outcome of interest, I'll just call it outcome, over total number of outcomes. Okay. So in this case, what's my total number of outcomes on this table here? 1, 2, 3, 4, 8, 12, 16. Agree?
Yeah.
Yes. So in this case, my total is always going to be 16. This number at the bottom here is always going to be 16. So my probability, I'm going to call it P for now, equals the outcome I'm interested in, O, over 16. The question's asking me, how many times, what's the probability of me getting the same number twice? So for me to get the same number of twice, how many times out of 16 does that happen? Well, it happens here, where my mouse is just flopping around now, once. It happens here, 2. It happens here, 3. And it happens here, 4, exactly. So my probability of getting the same numbers, in brackets I can write what the probability is, equals 4 over 16. If I simplify that, it becomes 1 over 4. Make sense?
Yeah.
Good. The total being less than 5. So what's the probability of me getting a total that's less than 5? So my total of less than 5, the probability of that occurring, the total number is 16 still. Less than 5, 1 plus 4 is 5. That doesn't work. 1 plus 3 is 4. 1 plus 2 is 3. 1 plus 1 is 2. So 3, 4, 5, 6. And I think there's about 6. If you add them up, they go to less than 5. Would you agree, Amar?
Yeah.
Yeah. So 6 out of 16 is less than 5, which is going to be 4 over 8, which is going to be, no, 3 over 8, sorry, my bad. I think the mark scheme's got something wrong here, but it doesn't matter. 3 over 8. Does that make sense?
Yeah.
So now, this is a nice, tough question. Well, not tough, but remember what we learned about earlier, exhaustive probabilities. It's about that. So read it, try and answer it. Part 1. So a lot of reading.
Exhaustive again. I didn't get a chance to write it down.
Oh, for the exhaustive one.
Yeah.
So when we say exhaustive, if you listen, you can write down what I say. It means all of the possible outcomes. When you're talking about something exhaustively, you're talking about all of the possible outcomes that can happen. So now, knowing that, when you look at K and G, those situations there on the exam paper, is that going to be talking about all of the possible outcomes or not?
No.
No, because K is talking about, go on, sorry, go on, Amar.
So it's false.
Huh?
The answer is false for A, isn't it?
Yeah, exactly. And why? Why is it false? We're going to justify it.
Because it's not talking about all of the outcomes, just talking about 2.
Yeah, exactly. It's only talking about the guitar and the keyboard. It's not talking about the kids that play drums. So you're going to miss some outcomes here. So K and G are not exhaustive. If everyone's okay with that, we can move on. If not, you can say something and we'll talk about it. Okay, seems like everyone's okay. Now, M and F. Are M and F exhaustive? Think about that. This one, I'm going to get someone else to answer. So Hannah or Khalid, whoever of you comes up with it first, you can tell me. Are M and F exhaustive?
I think they are because they're both like male and female that equals 1.
Exactly, because
I
look,
don't know.
you can only have males and females. So if I'm taking into account what the males are doing, if I'm taking into account the females, I'm having everything that's possible there. If there's male, female, and half-half, then M and F won't be exhaustive. But if you're looking at only males and females, then this thing only has males and females in it. And you're talking about all of them when you're talking about males and females. So they're exhaustive. Good job. Does that make sense, Hannah? You don't have to answer. If it does, you can just
Oh,
take
yeah.
Yeah, good. Well done.
Yeah.
Okay. Amar?
Yeah.
Excellent. So you can see how once you know the definitions, it becomes very easy. Now, K and D are mutually exclusive. Are K and D mutually exclusive? K and D.
No.
So,
No.
what do you say, Amar?
No.
No, why not?
Because somebody can play both instruments.
That's true. That's true. But at the same time, each student plays. Look at the question.
Oh.
It plays one main
Okay.
instrument. So if you're only playing one main, yeah, can you be playing two?
No.
No. So because each student can only play one main instrument, K and D, the student's main instrument is a keyboard, the student's main instrument is a drum. These have to be exclusive. If a student plays a keyboard, he only plays a keyboard, one main instrument. If a student plays a drum, he only plays a drum. So if he does one, he can't be doing the other, or she can't be doing the other. Okay, guys? If that's clear, I'll move on. If not, ask. Good. F and D are mutually exclusive. Let's look at F and D. Have I done F and D already? Yeah, F and D. Are F and D mutually exclusive? Somebody else, or whoever wants to answer can answer that.
Did you say F and D?
Yeah. So F
I think
said,
it is.
it is, yeah? Let's check. So look, there's a female can play guitar, there's some females playing keyboard, there's some females playing drums. Now, F is the student is female, okay? And D is the main instrument is drums. Can the female's main instrument be drums, or could it be something else as well?
Can be something else as well.
Something else as well. So basically, they're not mutually exclusive. A female can have drums, or it might be a female and a keyboard. It might be a female and a guitar. So F and D are not mutually exclusive. That's probably the hardest one to understand, but do you guys get it?
Yeah.
Okay. Okay, good. So you guys are learning well. You know the silence means you understand it. Now, number 6. We wrote some rules earlier on this. Try and do number 6. Just remember the rule and you'll get it. Check your notes if you can. So earlier we said, if two events are mutually exclusive and exhaustive, then when you add them together, you should get 1. If you guys remember that. And we also said in our notes earlier, if two events are exhaustive but not mutually exclusive, then they'll add up to greater than 1. Okay? This we're going to recap again later in more detail. For now, you just need to know how to use the rule. So are you guys okay with that?
Yeah.
Good. And for those who are quiet, it means you're okay as well, hopefully. Okay, we'll talk about that in more detail in the future, but for now, it's just about using the rule. Now, here we go, number 7. So number 7, I want to make it a bit smaller so you can see it, the screen. Let's try the first 3 parts. If you have any questions on this, on cards, let me know as well. We can have a break after this one if you guys want. Done. Okay, good.
I'm done as well.
Excellent. So what you guys are going to do, you're going to look at the first 3 on the mark scheme and mark your answer and tell me if you guys are getting it wrong or right.
Yeah, I got the first 2 right, but the last one I got 17 out of 52 instead of 16. You know how I got that?
You got 17 out of what? 50?
52, but I just added the probability of getting a heart and a king.
Yes. Don't forget, sorry, go on.
For C, I did 4 52 and 13 out of 52.
Yeah.
Yeah, and did you guys both get something a bit different to what they got?
Yeah,
I got 17 out of 52.
Yeah, we got
Okay,
that.
and you got the same, Amar. So
Yeah.
think about this, yeah? Let's look at this. The probability of getting a king is going to be 4 out of 52, yeah? The probability of getting a heart is what?
13 out.
Because what they've said is the king will be 4 out of 52, right? But in these hearts, one of them will be a king of hearts. Does that make sense? So
Yeah.
you're going to be repeating it in here. This king, that's 4 out of 52, you've put him in here again because one of them is the king of hearts. So what you can do instead of 13 out of 52 is call it 12 out of 52 so that you don't include the king of hearts in there because you've already included the king of hearts in this one. Does that make sense? Because the king of hearts has already been spoken about here, when you're looking at the probability of hearts, you've already put one of the hearts into there. So here, you can turn this into 12 out of 52 instead. This is another way of looking at it. I just want to show you the other way of understanding it as well. Do you guys get that?
Yeah.
Yeah? Khalid?
Yeah.
Okay. Hannah? Hannah's quiet, so I'm assuming you're okay, yeah? Okay, good. Now, the next one. The next part of this question says, explain. Now, this is the same thing. Explain why the answer to 3 is not the sum of the answers to 1 and 2. However, in this mark scheme, they're giving you a clue. So even in this exam, if you've got 17 out of 52, the next question tells you, look, why is the answer here the right answer, not the sum of the answers to 1 and 3? Why is it not the sum of 1 and 3? And 1 and 3 is the probability of a heart and the probability of king. Why can't you just add these together? Because there's a reason for it. The events are not mutually exclusive, meaning the probability of being a king and a heart can exist in both groups, in both situations. Yeah, the probability of being, let me bring this back up. The probability of being a king and a heart. These two are not mutually exclusive of each other. One of the kings exists in the hearts as well. Because they're not mutually exclusive, you can't always just directly add them. You can add 2 things, PA plus PB, and we learned this last week, when the 2 events are mutually exclusive. But when they're not mutually exclusive, when one of the things can go into the other one, it means something can be in both groups at the same time. The king can be in the group of kings, or he can be in the hearts at the same time. You usually add probabilities when they're both mutually exclusive. But when we add these, we'll get an answer that's slightly off of what they want. Because we can't add very easily, we don't use this rule of adding when things are mutually exclusive usually. Although it will get us an answer close to what we want, it won't get us exactly what we want. Does that make sense, guys?
Yeah.
A bit or 100%? Amar?
Yeah.
I get a bit.
I get a bit, yeah? So all you've got to remember is this rule here. Okay? Let me just remind you of the rule from last week, where we can use PA plus PB equals PA or B. If you want to find out the probability of A or B happening, yeah, you can add them together. If A and B are mutually exclusive, you can add probabilities when the two things that you're adding are mutually exclusive. When they're not, you have to think about it a bit more. That's all it is. So, for example, e.g., in a deck of cards, the probability of getting a king or a heart are not mutually exclusive. Why? Because the probability of getting a king is 4 out of 52. The probability of getting a heart is, like you said, 13 out of 52. So probability of A or B, one of these exists in there. So because there's a king in here as well, these two are not mutually exclusive with each other. So if I wanted to get a king or a heart, the probability of A or B, PA or B, I can't add them together. I can't add them together if I wanted to get PA or B. Why? Because they're not mutually exclusive. These two have to be mutually exclusive. Something that exists in one can't exist in the other one if I want to get the probability of one or the other. Yeah, if I want to get probability of one or the other and I want to get them in the old way that we learned, they both have to be mutually exclusive of each other. If they're not, if one of those things can exist in the second thing, then I can't just simply add them up to get the probability of one or the other. Does that make sense now?
Mm-hmm.
Okay, Khalid? Khalid?
Yeah. Yeah.
Okay, don't worry, we're going to cover this in more detail anyway, but we're practicing these questions to learn these things and make sure. Hannah, I think you're okay?
Yeah, I'm okay.
Yeah, good. Any confusion, just tell me, Hannah, yeah? Now here, some algebra mixed in with probability. Wait, before we carry on, let me ask you guys. Do you guys want a 5-10 minute breather? Tell me. So let's start with, go on, Hannah.
Yeah,
Okay, how many? 5, 10 or 15?
10.
10.
10?
Oh.
Okay, Amar?
10.
10. Khalid?
10.
10. Okay, so it's 15:08. It's going to be 15:09 or 3:09. We'll come back at 3:19. Okay, leave your computers on, don't turn them off, otherwise we'll log you off. Just come back at 3:19 and we'll carry on. Well done, guys. So think about this. I'm going to tell you guys about some concepts that we need to remember here. You'll see how easy it is in a second. So this is just algebra mixed with probability. First of all, if you look at my whiteboard, what should the total probabilities always add up to?
1.
1. Do you agree with that, Amar?
Yeah.
Okay. So there are 4 players in a tennis tournament. If you add up, then the probability of winning is written on the table over here, where my arrow is right now. Blah, 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 blah. 1, 2, 3, 4. The total probability of them winning should be what? If you add up all the probabilities, what must it get? What must it get to?
1.
1.
Right? So Andy has a probability of X. Let me just draw that out. Andy has X. Stan has a probability of X plus 0.1. Roger has a probability of 2x. And Rafa has a probability of 0.3. If you add up all of their probabilities, Andy's, which is over here, let me just put that into a different color because it makes it look better. If you add up Andy's, which is X, and then Stan's, you add it to Stan's, which is X plus 0.1. and then you add that to Roger's, which is 2x, and then you add that to Rafa's, which is 0.3, we should altogether get what number, guys? If you add them all up. You just said it a minute ago. Should get 1.
1.
Yeah, exactly. So if we add them all up, x plus, let's add all the x's up first, like terms. X, 2x. 2x plus x is going to give you 4x. 0.1 plus 0.3 is going to give you 0.4. So 4x plus 0.4 equals 1. Now, if you rearrange this, 4x equals 1 minus 0.4, which gives you 4x equals 0.6. So x, if I divide this side by 4 and that side by 4 to get x equals 0.6 over 4. 0.6 over 4 will give me 0.15. Let me just double check that on my calculator. 0.6 divided
Yeah,
by
0.15.
perfect, yeah? Equals 0.15. So now I know from this that x equals 0.15. I'll put that in a little box. Right. So now that I know x is 0.15, the probability of Stan winning, which is what the question's asking me, is x plus 0.1. It says calculate the probability that Stan wins. So Stan winning is x plus 0.1. That means his probability of winning is going to be
Is 1/4.
0. Well, let's check it. Good. 0.1, yes, plus 0.15, which gives us 0.25, as Khalid said, and 0.25 is your answer. Or you could even say 0.25 out of the total, because that's a total. 0.25 out of the total, which is 1, equals 1 over 4. Good job.
Would they mind if you left as 0.25?
No, they wouldn't mind. They wouldn't mind. Unless they tell you to put in a fraction, you don't have to. Does that
Okay.
make sense now?
Yeah.
Okay, Amar?
Yeah.
Sure?
Yeah.
Okay, good. All we've got to remember is our rules. And our rules are that everything adds up to 1. So all of these in here must add up to 1. From that, we can find x. When we find x, we can start putting it into these. Hannah, I'm going to carry on because I think you're okay with it, unless you say you're not. So, good. Now, next one. So here. Let me just escape that a little bit. It's getting a bit too big. So a group of children is asked, what is your favorite animal? The results are given in the table below. I want you guys to think about this question here. Question number 9. Have a nice little go on that one. After you do part A and part B, tell me if you've done it and we'll go through it. If you guys carry on like this in this lesson, you're doing well. I think by summer you'll have done everything you need for your GCSEs, and we'll just be practicing a lot of questions. So by next year, when you go into school, you'll be sailing through maths. I don't even think you'll need a tuition next year in maths. Maybe you'll probably just come to it and practice if you do. Inshallah.
You have to add up all of the people and then
Yes, you have to add them all up and then put the boys out of the total. Does that make sense, Samar? Samar?
Yeah.
Okay, good. So once you do part 1 and part 2, guys, you can tell me, whoever does it, and we can go through it.
I've done it.
Done it? Okay. So because you've done it, I'll go through it. And even if you haven't done it, as long as you know the method, you're good. Well, obviously, it's not always enough to know the method. You need an accurate answer in exams as well, which is very, very important. So we're going to look at that now. So the total number of boys I got from counting was 72. And the total number of children is 140. So the probability of getting a boy is 72 out of 140. That's your first one. Okay, if everyone's okay with that, because no one's complaining, we can move on. The favorite animal being a horse. Well, what it is, 8 of the boys like horses and 18 of the girls like horses. So it's 26 out of a total, which is 26 out of 140. Then, number 3 and number 4.
Are you allowed to simplify them?
You can simplify them. Even better if you simplify them, to be honest. Okay. Now what we'll do here, I'm going to copy this diagram over to here so you can see it. You might need it because you'll need it to do this question. Paste it. So using that diagram, we're going to do part 3 and part 4. So we've done part 1 and part 2. We're going to do the rest of them now. So here's your diagram. Here's your questions. Use it to help you do your questions. So you're going from B now. As soon as you do it, tell me. Remember, the probability of something not being there is 1 minus the probability of it being there. So the probability of not a dog is 1 minus the probability of being a dog. You can also do it in different ways just by looking at the table. There's so many ways to do that question. As soon as any of you finish, tell me, please. We can move on. After we do probability and tree diagrams and everything, we're going to go look at averages,
Yes,
detail. Done, Amar?
yeah, no, that's it.
You know how to do it?
Yeah.
Good. Let's go through the answers to make sure. So as we said, if one of you do it, we go through the answers just to save on time and understand it. So we're going to get for 2, 3B. For the first one, BI, I'm getting 20 out of 68. Okay, check your answers, make sure it's all right. For the second one, I'm getting 54 out of 68. And for the third one, I'm getting 10 over 22. So I'm going to move on to the next question. If I assume you guys got that, and well done if you did. Even if you didn't, don't worry. I think you all did. I'm going to move on to the next question if no one tells me to slow down. Okay, so that means you all understand it. If there's any questions you can ask now, or we can move on. Good. Last question in this exam paper, but by no means the last question in the topic, because we've got a few more bits of the topic we're going to cover, although we've done most of it. Try this question out here. Number 10. As soon as you finish, tell me.
I think I know it.
Okay, tell us what you think.
Would it be 5 over 5 plus n?
Very, very good. So I'm going to explain this to you guys. Even though it's been done nice and quickly, we're going to explain it just to make sure. Let me find my little, take the mark scheme off because we won't need it in a second. Let me find my whiteboard. One second. Smooth draw. Here we are. Can you guys see the whiteboard? One person
Yeah.
can. Yeah, good. So let's look at the question and let's compare it to our whiteboard. It's pretty easy. Okay. So a bag contains n white discs and 5 black discs, yeah? So n white, so we don't know what the number of white is, 5 black. So your total is going to be 5 plus n. Then you're taking out a disc at random. What's the probability that we're going to be black? So the probability that you're going to be black, the one that you're interested in is blacks. You know the probability of black is 5 over the total, which would be 5 plus n. Because when you're looking at the probability of something, we look at what we're interested in over the total. In this case, the total is 5 plus n. What we're interested in is 5, because they tell us that in the question over here. And then we can just put it into a equation. Notice when I write a probability equation, on this side of the equal sign, I write P bracket B. Because I need to I need to explain what I'm talking about. And I'm talking about the probability of getting a black, which in this case is 5 over 5 plus n. Okay, so that's that part done. I want to make sure you guys understand it though. Do you get that, Amar? Amar?
Yeah.
Yeah. Hannah, you okay with that?
Yeah.
Good. So we've completed an exam question, GCSE higher question paper. This is taken from an exam paper on probability. As you can see on the board, it's a higher paper, it's probability, it's worth 40 marks. It's made specially by the examiners to teach people what kind of stuff comes up in the exam. However, they've missed some things out here. They haven't spoken about tree diagrams. We're going to do a little bit more on that as well. So I'm going to give you guys a 2-minute breather while I pull something else up. Yeah, just stay there with the computer. Well done. We've done one exam paper completely, so it's really, really good. Now I'll go into some other stuff. Okay. Okay, so we've only got 20 minutes left for this lesson. So it's good to start looking at some examples of tree diagrams. I'm going to make you practice this a bit, guys, today, a little bit next week, and then we can move on to other stuff. So I want you to read the situation here and then try and construct a tree diagram of the situation, okay, in as best way as you can. Read what the PowerPoint says from the top. It will help you. If you have any questions on what any of it means, just ask. After you finish your tree diagram, tell me, and we'll go through it.
I'm done.
Done? Excellent. So let's look at it. Now, let's look at some of the language here and remember what this is talking about. Tree diagrams can be used to help solve problems involving both dependent and independent events. If one thing depends on another thing, then you can use a tree diagram for that. If two things don't depend on each other, we can use a tree diagram for that as well. We're going to look at more detail in that later, and we spoke about it last week too. So on my tree diagram, I have this. It's going to make some noises. And for my first choice, my second choice, okay. So when you're going across the diagram, if I want to get the probability of red and red, I multiply. I'm going along the branches. So for me to get a red and red, 9 over 100. For me to get a red and blue, I'm going along a branch again. So what I do, 3 over 10 times 7 over 10, 21 over 100. Again, multiply. And again, multiply. Does that make sense, guys?
Yes.
Good. Perfect. Okay. So now we're going to move on. Again, if you're not answering, it's all good because I understand that it makes sense to you. Now, look at the tree diagram, how it's working. I'm going, just this is an important point here. Probabilities are multiplied along the arm. Okay. So if you're going along the arm, you're multiplying. If you're looking at the probability of something and something else, and they're on different arms, they're on different places, then you simply add the arms together. So multiply along the arm. If you're looking across arms, you add. So for example, I want you to do a more involved question now before we finish lesson. Try this out. So draw a tree diagram and do part A and B, B1 and B2. Take your time. We've got some time. Then we'll move on. Done, Khalid?
Yeah.
Okay. Let's give the rest of you 2 more minutes, Khalid. Yeah, we're going to give the rest of them 2 minutes, the rest of the class, unless they tell me they're done as well, and we can go through it now. So let's give 3 minutes, actually. 3 more minutes and we'll go through it. You can have a little break as a reward, Khalid, for 3 minutes. So does it feel different at home, Khalid, now with the situation? Everyone's at home. You see your family every day, all the time.
Yeah. More annoying.
Everyone gets tired of everyone.
Yeah.
Oh, I can imagine. What are you doing to pass time?
PS4.
PS4.
I'm done.
Okay, nice. Gonna wait another 1 minute or 2 minutes for Hannah, and we're gonna carry on. Are you watching Money Heist, Khalid?
I need to
I'm
start it.
done.
Done? Excellent. Okay. Let's start
I'm
looking
watching.
at. You're watching that, Mar? Is it good?
Yeah.
It's addictive, I'm hearing, because a lot of people are saying that.
I watch Money Heist as well.
Oh, yeah.
Yeah, it's so good.
Okay. Hannah wants
Someone
to-
died.
Are you watching the new season, Hannah?
Oh, yeah. I thought I watched it today.
I'm going to start watching it today because I'm hearing a lot of good things. Okay, good. So let's give you this PowerPoint. Look at that. There's your answers. I want you to look through it. Make sure your probabilities are right. 2 green is going to be 20/81, I believe. A black followed by a green is basically the 2 black and greens added up because they're across different branches. So I'll show you that second one. Make sure you're right in A and B part 1, and then B part 2. We'll look at that in a second. And we're only going to have 10 minutes left, so we might do 1 or 2 more examples of this and call it a day. How's your answers looking, Amar? Were they okay?
Yeah.
Okay, you corrected it?
Yeah.
Okay. So if everyone else is okay with that, I'm going to move on. 2 green beads, you should be getting 25/81. A black followed by a green. Now, black followed by green, as you can see with my arrow, is going to be this one over here on this branch. Yeah. And this one over here. But they're saying a black followed by a green. So a black followed by a green means the green one comes first and the black one comes second. So it's this one. If they asked you for black and green, you'd get both of these and you'd add them together because they're on different branches. Hope that makes sense, guys. So what we'll do, let's go a few ahead. I want you guys to try this one now, question number 3. We'll have time for 1 or 2 more, and then we can move on. After we do this, your probability is more or less sorted. Inshallah. Someone has joined the party. Marco. Hello, Marco. Let him, he'll talk in a second. Marco's coming early today.
Hello?
Hello, Marco. How's life? You okay, Marco? Good. You know, science starts at 4:15, Marco, yeah?
Okay.
No problem. Stay on. You can stay on. Just leave your computer on and you can return at 4:15.
Oh.
Okay. Good. So, as soon as one of you guys finishes, Amar, Hannah, or Khalid, let me know.
I'm done.
Done? Okay.
Yeah.
So, we're going to go and look at the answers for this. I'm getting these as my probabilities. First of all, are you getting the Amar?
Yeah.
Good man. So we've completed the tree diagram. We've done part A. If everyone else is getting the same thing, good. Use your tree diagram to calculate that Peter wins both events. For Peter to win both events, it's going to be this one, this branch here where my arrow is, and this branch here. So 0.4 times 0.3. For Peter to win both is going to be 0.12. The probability that Becky loses the race but wins at tennis. So Becky loses the race but wins at tennis. For Becky to lose the race, what's her probability going to be?
0.4.
Well, for Peter to win the
I'll
race.
show that P.
So yes, exactly. For Becky to win the race is 0.6. For Becky to lose the race is going to be 0.4. Good. Okay. And then for Becky to win at tennis, it's going to be 0.7.
7.
Yeah. So 0.4 times 0.7 will give us our answer, which is 0.28. It's a complicated one. Does that make sense, guys? If
Yeah.
it does,
Yeah.
good. We're going to move on. It's now 15:52. We've got 8 minutes. Enough time for one more question, maybe. All right. Let me give you a question on this. Let's do this. I think we've done this one. Okay. No, this is a bit different. This is very good. Try this one, guys. Last one. Without replacement. We learned about this last week. And then do the questions at the bottom. As soon as any of you are done, you can tell me.
I'm done.
Done. Okay, good. I want to start going through it in about 2 minutes, unless all of you tell me you're done, then I can go through it quickly.
I'm done.
Done. Excellent. And Amar, let's give it one.
Yeah.
Yeah? Okay, let's go through it. So here's my tree diagram, and there's my numbers. I want you guys just to check it and tell me when you finish checking.
Yeah.
Good, Amar. You okay with it?
Yeah.
Good
Yeah,
job. Those are the harder ones, these two diagrams, because we're not replacing. So people can make mistakes on these. Gonna wait for Hannah and Khalid, and then we're gonna move on. So Amar, do you feel you're learning well in this type of lesson?
Yeah.
Yeah, good.
Yeah.
Do you prefer it to like coming to the center?
I don't mind.
You don't mind either? Okay.
Also, yeah.
Your maths is quite good, Amar. I've got to say, like when you first came to the centre, you said you're not that good at maths, and then you showed me what you could do. I realised you are pretty good, mashallah. It's just you need practice, but your maths is you understand things, so it's good.
Mm.
How about you, Hannah? You feel you're learning this way?
Yeah.
Good. Do you prefer it to the centre or do you prefer online, or both?
I don't.
You're not sure. How about you, Khalid?
I don't mind.
No, mine's good. Have you all checked your answers? And we're all okay. If no one says anything, we'll move on to the last one, yeah? A last quick one we'll do, and then we're done. So, let's check. Let's do this last one. That's all, yeah? You guys have worked very hard today, so keep it up. Well done. Those of you who are staying for science after this, you can stay in the same room. We'll start science at 4:15. Those of you who are not, about 4 p.m. when we finish, you guys can leave. In about 2 minutes, I'm going to put the answer up quickly. I'm going to check it, and then we're going to finish. Okay.
I'm done.
Done? Okay, let's go through it because time's running out. Let's give it 1 more minute, and then we're going to go through it at 15:59.
I'm done.
Excellent. So it's going to be another, I think most of us are done. Just going to wait another 10 seconds till my clock hits 1 minute to 4. And then we're going to finish off. Here we are. Okay. So your answers are going to look like this. Check your answers. We've got 1 minute left. Tell me if there's any issues. If not, very good. And we'll talk about the next lesson quickly.
I simplified.
You simplified it, but otherwise you're correct, yeah?
I think so.
Yeah,
Yeah.
I got it
Well, I
right.
did it on a calculator.
That's fine. You got it right, Amar, as well. Hannah, you okay with it? Hannah, you okay? Yeah? Okay, I'm going to assume you're okay, Hannah. If not, let me know. So, guys, that's excellent. We finished the lesson off on probability. We've completed probability completely. If there's any, there might be 1 or 2 loose strings, small minor things which will tie up. But now probability should be done. What I'll do, I'm going to send you, I've already sent some of you the exam paper that we done today. For those who I haven't, I'm going to send it to you. As a homework, just go through the paper now, looking at it. And just to make sure mentally you know how to do all of the questions. And if you get stuck on any of them, look at the answers you've done today and just recap it for yourselves, okay? So it'll be a good revision to get it solid. Also, the video of this lesson is available on YouTube. I've emailed some of you the videos from last week's lesson. I'll email the rest of you, hopefully, in the next 2 days. And good. So, well done, guys. We're going to complete the lesson now. And have a good week.
All right, thank you.